Hello, friends. We are moving on to another topic, binomial theorem. And by the end of this lesson, we'll be able to expand any given binomial expansion that will be given to us. Now, let's look at this. So we are considering two binomial, 2a plus b. Now, from indices, we saw that anytime we have a number raised to the power 0, it gives us 1. And so a plus b, all raised to the power 0, is 1. So we say the expansion is 1. And then the coefficient will be 1 for this first row. Now, a plus b, all raised to the power 1, will give us a plus b. So the coefficient of this is 1, the coefficient of that is 1. So when we want to write the coefficients, then we have 1 and 1. Now, if we move on to a plus b all squared, over here, it's like a plus b into brackets, brackets open, a plus b. Then when we multiply them out, as we know already, then that will give us a squared plus 2ab plus b. And that is how that also goes. All right, so that is a plus b. And so that actually gives us that value, right? So let's write a plus very well. And so that gives us our plus. That gives us our plus. Okay, so let me take my time and write it very well. So we have a squared plus 2ab plus b squared. So here the coefficients are 1, 2, and b squared. That is 1, 2, 1, 1, 2, 1. And so we get 1, 2, 1. Now when we go to a plus b cubed, that also the coefficients are 1, 3, 3, 1. And you look at the pattern that runs through. Over here, we pick the highest power, so a squared. The b is there, but it's b raised to the power 0. Then move on to this time, we reduce this by 1 and we add it to the b raised to the power 0. So we get a raised to the power 1, b raised to the power 1. This time we reduce the power here by 1. So we get a raised to the power 0 there. We increase this by 1. So we get b squared, whereas the a here is a raised to the power 0. So that's how it is done. And then we now put the coefficients there. Now, if you look at this, we now have a plus b all cubed. So we follow the same trend. So a will pick the highest power, a cubed, with b raised to the power 0. And then we also have our a squared. We introduce our b raised to the power 1. Then with our 3, a b squared plus b cubed with our coefficients 1, 3, 3, 1. It means that if you want to take your time and multiply them out, it means that over here, we are going to multiply the whole of this by a plus b to get a plus b cubed. If you want to get a plus b all raised to the power 4, it means the result we have here, we are going to multiply it by a plus b, and that will be tedious. So there is a pattern that runs through. But if you look at under the coefficients, we have a triangle there, and that triangle has given us a triangular array, and that is known as the Pascal triangle. So we can continue on and on. You could see that from the first row, we started with 1 and then ended with 1. So 1 plus 1 gives us 2 with 1 beginning, 1 ending. Over here, we have 1. So 1 plus 2 is 3. 2 plus 1 is 3. And then we end with 1. It goes on and on. We start with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1, 4. And then we end with 1. So by so doing, we'll be able to generate all the powers for every binomial expansion, and that was derived by Pascal. So let's look at more examples. Use the Pascal triangle to expand a plus b raised to the power 4. Over here, I want to remind ourselves that anytime you are going to compute this, remember that you need to add 1 to the power. So if the power is n, then the number of terms will be n plus 1. So for this one, we have 5 terms. So you bear in mind that when you finish, when the power is 4, you get 5 terms. When the power is 5, you get 6 terms, and so on. And so for our solution, from the Pascal's triangle, the coefficients for the above question are 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. So these are the coefficients that we'll be using. So we move on. A plus b raised to the power 4. So a raised to the power 4. Our b is there by raised to the power 0. So 1, the coefficient 4, a cubed b raised to the power 1, 6a squared b squared plus 4a raised to the power 1 b cubed plus b raised to the power 4. Great. So that does it for this type. So this is b raised to the power 3 and then b raised to the power 4. So that ends everything. Let's move on to question 2. Expand 2x plus 5y all raised to the power 3. And so using the Pascal triangle. And so from the Pascal triangle, Pascal is telling us that the coefficients will be 1, 3, 3, 1. So we go through the motions. Our first term is 2x. Our second term is, the other term is 5y. So 2x all raised to the power 3 times 5y raised to the power 0. The coefficient here is 1. The coefficient here is 3, then 2x all raised to the power 2, 5y raised to the power 1, plus 3, 2 times 2x times 5y raised to the power 2, plus 2x raised to the power 0, and then times 5y raised to the power 3. So we take our time and simplify each of them. 2 times 2 times 2 is 8, and then x cubed. Then 5y raised to the power 0 is 1. So we have our 3. 2x all squared will be 4x squared, and then 5y. Then the next one, we get 3 times 2x. Then 5y squared will be 25y squared. Then finally, we go to the end. So 5y raised to the power 3. So 5 times 5 times 5, and then y cubed. That will be 125y cubed. So we take our time and do the simplification. So this one will give us 8s cubed, as said already. Then this will give us 4, and then s squared. So 3, 4, 12 times 5. Then we get our value 60, just as we've done over here. All right, so this one's with 3 times 2x times 25. That will give us 150xy squared. Then finally, 125y cubed. That's great. So you look at the steps and see how we did them. Question 3, expand 3x minus 1 over 5 all raised to the power 4. So from the Pascal's triangle, the coefficients for row 5 are 1, 4, 6, 4, 1. So we go through the motions again for this question. So 3x all raised to the power 4. And then our coefficient here is 1. So 4, 3x raised to the power 3 minus 1 over 5 raised to the power 1. Then 6 into 3x all squared. Then 1 over 5 minus all squared. And then we'll move on to 4 times 3x times negative 1 over 5 all cubed plus 1 over 5 negative all raised to the power 4. So we take our time and then simplify them. So over here, 3 raised to the power 4, x raised to the power 4. So 3 times 3 times 3 times 3, that will give us 81, x raised to the power 4. We come here, this raised to the power 3 will be 27, and then x cubed. So we have it this way. So this negative, we'll put it there. So negative times positive will be negative. Then this side 6 times, this is 3 squared x squared, so we shall get 9x squared. Then negative, we are squaring it, so we shall get our positive will now come. That will be fantastic. So we also need to look at this one carefully. So this will be 25 because we are actually squaring. That is very, very important. So we look at that carefully. So we shall get our values straight away. So this will be 6 times 9x squared. And then this one also we are squaring, so we shall get 1 over. So our value will be a positive value that we need to look at it carefully. Fantastic. All right. So that does it. And then we come to this side as well, and we'll look at that also. Okay, so we have 4 into 3x and then 1 over 25. So we take our time, multiply that, and that'll give us our 12x on. All right, so we come here, and then this will give us 1 over 625. So, okay, so let's look at this one. So 6 times this is our 50, 6, 9, 54. So that'll be 54 over 25. That's it. So the simplification will give us the whole of this. we get 81 x to the power 4, this s cubed, that s squared, and this and that. All right. So that does it for this question. All right. Now expand x minus y all raised to the power 6. So for our solution, we're saying that from the Pascal's triangle, the coefficients are 1, 6, 15, 20, 15, 6, and 1. So we start. And so x raised to the power 6, and our 6 will come x raised to the power 5, our minus raised to the power 1, 15, x raised to the power 4 minus y raised to the power 2, 20 s cubed minus y cubed, 15s squared minus y raised to the power 4, 6x minus y raised to the power 5 minus y raised to the power 6. So we take our time and then we do the simplification. Okay, so this will give us s raised to the power 6. Over here, we got our minus 6s raised to the power 5y. Over here, we shall get 15s raised to the power 4, y squared positive, then 20s cubed, then this will be minus y cubed, so the minus will come here. Then we get 15s squared, and then this will be positive, so y raised to the power 4. And over here, we shall get 6x, then this will be minus y raised to the power 5, so the negative will affect the whole of this. Then we have this minus y raised to the power 6 will be positive y raised to the power 6. So that does it for this aspect, right? I want to look at example 5. Expand 3x minus square root y all raised to the power 5. So from the Pascal's triangle again, the coefficients are 1, 5, 10, 10, 5, 1. So we go through the motions. So 3x all raised to the power 5, 5 into 3x raised to the power 4 minus root y, 10 times 3x all raised to the power 3 minus root y raised to the power 2 plus 10 times 3x squared minus root y cubed, and then plus 5 times 3x times negative root y raised to the power 4 plus negative root y raised to the power 5. So we want to take our time and do the simplification. So this one, 3 times 3, 5 times. So that'll give us 243x raised to the power 5. And then 3 times 3, 4 times give us 81 times 5. That will give us 405 x raised to the power 4 with our negative square root y. So the negatives comes. And over here, we shall get 3 times 3 times 3, 27 times 10. And then that will be 270. And we are squaring this, so we shall get y. So that's why we have the y here. And then this is 9. That's 3 squared is 9. X squared times 10, 90. And so the 90x squared will come. Square root y times square root y is y. So I get another square root y, which is y raised to the power half. So we shall get our y times y raised to the power half. And when we compute that, we shall get y raised to the power 3 on 2. Good. And so we now look at the next one, 5 times 3, 15. And then this will be positive. So y square root y times square root y is y. Square root y times square root y is y. And the minus will go to positive. So we shall get 15xy squared. And finally, we come here. Square root y times our square root y. That will give us our y times y. So we get y squared. Then the square root will give us y raised to the power half. So when we compute, we get 5 on 2. Good. And so when we take our time and do the simplification, we shall get 243s cubed for this. 405 x raised to the power 4, y raised to the power half, 270 x cubed, and then y minus 90 s squared 3 on 2, s squared y raised to the power 3 on 2 plus 15xy squared, then minus y raised to the power 5 on 2. That is great. We are moving on to factorials. So we want to explain what factorials are. So factorials are denoted by n with this exclamation mark, and they normally represent the product of all positive integers from 1 to n. And so mathematically, that is defined as n factorial is equal to n into n minus 1, n minus 2 times n minus 3 times 3 times 2 times 1. So reduce the value until you get to 1, and then you find the product. Yes, and so that gives us the factorial. Now, by convention, 0 factorial is 1. By convention, 0 factorial is 1. So example, 4 factorial is equal to 4 times 3 times 2 times 1. That is that. And so that will give us 24. 3 factorial is 3 times 2 times 1. That is 6. So we can add other examples as well. I want to explain what is termed by combinatorial numbers. So let's define it. And this is NCR. That is N choose R, or we can write NR this way. And we define it as N factorial over R factorial minus N minus R factorial. Or we can also use this expression as well to explain that. So both can be used. Example, so we want to find 5, 3, and that will be 5 factorial over 3 factorial times 5 minus 3 factorial. And when we do that, we shall get 5 factorial over 3 factorial times 2 factorial. So for 5 factorial, I get 5 times 4 times 3 times 2 times 1. Then 3 factorial is 3 times 2 times 1, of course. And then 2 is 2 times 1. So 2 times 2 is 4. That will divide this. 3 will divide this. So we shall get 5 times 2, 10 times 1, 10. So the value is 10 for this example. Now, I want to find this value if 5 factorial times n factorial over n minus 1 factorial times 4n is equal to p. Find p. So we want to do that. So we have 5 factorial. And so we shall write 5 times 4 times 3 times 2 times 1. Now, n factorial, we can write it as n into n minus 1 factorial. You already have n minus 1 factorial here, 4 times n. So this n minus 1 factorial will divide this by 1. And then 4 will divide 4. This n will divide that n. So we'll be left with 5 times 3, 15 times 2, 30. So p is 30. That's how we solve some of these questions. Now solve 10 into n minus 5 factorial equals n minus 4 factorial. So let's see how we can do that. Now, and so from the question, we have 10 into n minus 5 factorial. And then the n minus 4 factorial, we can write it as n minus 4 factorial times n minus 5 factorial. Okay, so with that, we divide both sides by n minus 5 factorial. So this will divide that, this will divide that. We shall get 10 equals n minus 4. Then when we rearrange, we add 4 to both sides. So we shall get n is equal to 10 plus 4. And so our n is 15. That's great. Now we should note that the expansion of a plus b raised to the power n, we may use a combinatorial method, and that is done this way. So a plus b all raised to the power n, we can find n 0, then a raised to the power n, b raised to the power 0, plus n 1, a raised to the power n minus 1, b raised to the power 1, then plus n2, a raised to the power n minus 2, b raised to the power 2. We move on and on until we get to this. Finally, we get to nn, then a raised to the power 0, b raised to the power n. So the combinatorial method can be used to expand. You can also use the factorial method. And when we do that, we have it this way. So a plus b raised to the power n will be a raised to the power n. Then a times a raised to the power n minus 1b plus a into plus n into n minus 1 times a raised to the power n minus 2 b raised to the power n b raised to the power 2 all over 2 factorial, plus we can move on and add n minus 2 to this, and that will be 3 factorial. And then we just subtract from this as we've been doing until we get to this point. Then finally get to n times a b raised to the power n minus 1 plus b raised to the power n. That does it with our k ending. So that does it for the expansion. Whether the combinatorial or the factorial methods, you actually get the same answers. So example, expand a plus b all raised to the power 5. So we want to use a combinatorial method. So when we do that, a plus b raised to the power 5. So we have the combinatorial method, 5, 0, a raised to the power 5, b 0, plus 5, 1, a raised to the power 4b, plus 5, 2, a raised to the power 3, b raised to the power 2, plus 5, 3, a raised to the power 2, b raised to the power 3, plus 5, 4, a raised to the power 1, b raised to the power 4, plus 5, 5, b raised to the power 5. If you take our time and compute, we shall get a raised to the power 5, 5, a raised to the power 4b, plus 10, a raised to the power 3, b raised to the power 2, plus 10, a raised to the power 2, b raised to the power 3, plus 5, a raised to the power 1, b raised to the power 4, plus b raised to the power 5. So that is the combinatorial method, we can use that and we will get it. Let's use the factorial method. And so that one, to when we expand, a plus b raised to the power n will give us the whole of this. Look at it carefully. Look at it carefully. So it just ends like that. All right. So I want to use it on this. So a plus 5, sorry, 8 plus b all raised to the power 5. So a raised to the power 5 plus 5 times a raised to the power 4, b plus 5 times 4, a raised to the power 3, b raised to the power 2 over 2 factorial. Then 5 times 4 times 3, a squared times b cubed over 3 factorial. 5 times 4 times 3 times 2, a raised to the power 1, b raised to the power 4 over 4 factorial. Then 5 times 4 times 3 times 2 times 1, b raised to the power 5. And then 5 raised to the power 5, b raised to the power 5 all over 5 factorial. And so when we actually do that, it means we will get all the values that we are actually looking for. And so when we do that, then we can now simplify. So a raised to the power 5 will come. 5 times a raised to the power 4b. Then when we come here, 2 factorial. So we shall get 20 over 2 when we come here. 5 for 20. Then times 360. Then 3 factorial is 6. So we can do that. When we come here too, we do same. So 5 times 4, 20. Then 3 times 2, 6. That will give us 120. And then 4, 3, 2, 1 will give us our 24. Good. So that will give us 24 for that factorial. And then when we compute all this, 5 factorial over 5 factorial will give us 120 over 120b is the power 5. So if we take our time and simplify, then we shall get the whole of this expression. We shall get the whole of this expression. So let's look at it carefully. Let's look at it carefully. There's our b here. That's great. Okay. That's great. So look at it. If there's any omission, we can all rectify it. That's fantastic. Now, we now want to look at the binomial expansion of 1 plus x raised to the power n. And so using all that we have studied, we can write it this way. So 1 plus nx plus n into n minus 1 s squared over 2 factorial. It goes on and on. So the next one can be n into n minus 1 into n minus 2 s cubed all over 3 factorial until we get to a point where we get x raised to the power n. So we can use this to solve a lot of questions, and the n holds for positive or negative, and any of them we can do it. Example, expand 1 plus 3x raised to the power 5. So solution. So it will be 1 raised to the power 5. So you get there. So you just pick the 1. 5 times 3x plus 5 times 4, 3x squared over 2 factorial, 5 times 4 times 3, 3x cubed over 3 factorial, 5 times 4 times 3 times 2, 4, 3x all raised to the power 4, 4 factorial, and then 5 factorial over 5 factorial, 3x all raised to the power 5. So let's take our time and simplify. So 1 comes 5 times 3, x, 15x. These 2 will divide that. So we get 10, and then this is 9, so x squared, so we get 90 s squared. We come here, 3, 2, 1, so 3, 2, 1, and this will give us 27. So this 3 divided 6 here, 2 goes into that place, so we get 10, and this 27, so 270x. And when we get here, 4 factorial, so 4 times 3 times 2 times 1, that will divide this, then we shall get our 5 there. And the whole of this is also 3 times 3 times 3 times 2. So that will be 81. X raised to the power 4. So 81 times 5 will give us 405 x raised to the power 4. Then finally, we get this, the whole of this will give us 1. So 3 times 3 times 3 times 3 times 3 times 3, 5 times will give us 243x raised to the power 5. Fantastic. So that's how we go about this. You can try your hands on a number of questions, and if you face any problem, we can discuss them. So that does it. Sometimes we can be given some values and be asked to express them using the binomial expansion, maybe 2.99 or 1.998 and so on. So you need to try and find a way and write them in such a way that you can use the binomial expansion to simplify it. And this comes from ingenuity. For more that we have studied, you'll be able to do it without any hassle. Thank you so very much for your time, and thank you for availing yourself for this program. Hope to see you again another time. Bye.